Look at section 7.3, operations with radicals. We're going to look at adding and subtracting radicals, and then multiplying radicals, and something called a conjugate. I don't think we've introduced yet in this course. Okay, operations with radicals, adding and subtracting radicals. In order to add and subtract radicals, the radicands must be the same. So when you add or subtract radicals, they must be like radicals. So what that means is they must have the same radicand. And also the same index. So for example, if I want to add 3 root 5 and 4 root 5, radicands are the same. They're both the square root, so the indices are the same. So that just becomes 7 square root of 5. The second one, the radicands are the same, both w's. The indices are the same, both 4's. So I have then the fourth root of w minus 6 times the fourth root of w, which is going to give me minus 5 fourth root of w. In number 3, we can look at those with the same radicands. So I have the square root of 3 and negative 4 times the square root of 3, which will give me negative 3 square root of 3. Then I have the square root of 5 and plus 6 times the square root of 5, which will give me 7 square root of 5. Number 4, now we're looking at the third root. So I have to look at the radicands. I have a 6x and a 6x. They have to be the same in order for me to combine these. That would make them like terms. 3 times the third root of 6x plus the third root of 6x is going to give me 4 times the third root of 6x. Then I have another radicand, which is just x. I have 2 times the third root of x plus 1 times the third root of x. So I have plus 3 times the third root of x. So the radicands must be the same. In some cases, we can try and get the radicands to be the same in order to add them. For example, when I have the square root of 8, I realize that I can write that as the square root of 4 times the square root of 2. Then the square root of 18 is the square root of 9 times the square root of 2. 4 is a perfect square, so 2 root 2. 9 is a perfect square, 3 root 2. This answer becomes 5 root 2. So if they aren't the same, maybe I can get them to be the same. And if I can, then I can combine them. Number 6, I have the square root of 2x to the third minus the square root of 4x squared plus 5 square root of 18x to the third. So the first thing you want to do is simplify these. The first one, or the first term, becomes x square root of 2x. The second one actually just becomes the square root of 4x squared, just becomes 2x. And then the last term becomes 5 times 18, can be rewritten as 9 and 2. Square root of 9 is 3, so 5 times 3, x squared square root of 2x. So here I have x square root of 2x minus 2x plus 15x. Sorry, that's just an x, not an x squared. X square root of 2x. So now my like terms are 1x times square root of 2x and 15x times the square root of 2x. So this will become 16. Let's see, negative 14x square root of 2x minus 2x. Number 7, when I want to look at simplifying these, I have the third root. I'll take a little more time with this one and try to write a little more detail. This becomes the third root of 2 to the fourth, x to the fourth, y to the third, minus the third root of 3 to the third times 2 times x to the fourth, y to the third. So now look at simplifying each of those radicals. I will be able to bring out a 2. 2 to the third is our perfect cube, an x and a y. That will leave me the third root of 2x. In the second term, I have 3 to the third. The cube root of 3 to the third will be 3. X to the fourth, I'll bring out an x and a y. Then I have the third root of 2x. So I can combine these because the radicands are the same, the indices are the same. This becomes minus xy third root of 2x. Multiplying radicands, multiplying is actually easier than after subtracting. When you multiply, you'll multiply any coefficient or integer on the front together. So in this case, I get 20. Then you'll multiply the radicands together, which will give me the square root of 18. Then you want to simplify that. That becomes 20. Square root of 9, square root of 2. Square root of 9 is 3. Remember the operation between the 20 and the square root of 9 is multiplication. This becomes 60 root 2. Okay, in number 2, multiply the radicands together. That's going to give you the square root of 18a to the third. Again, rewrite that as all of the perfect squares and non-perfect squares, if that helps. So the square root of 9, square root of 2, square root of a squared, square root of a. That becomes 3a square root of 2a. You can write all that out. If it's better for you, you can skip all that detail. It's not necessary to write it down as long as you see how to handle those. Okay, number 3, again, indices are the same, so we can multiply these. That is one thing to remember when you're looking at these like bases, is that in radical form, we want the indices to be the same. So I have the third root of 4 times the third root of 4. That's going to be the third root of 16. That becomes the third root of 8, third root of 2, 2, third root of 2 as my answer. Number 4, again, you're multiplying, so you multiply those numerators together, so you'll have the fourth root of x to the fifth over 16. You can rewrite those if you want. Fourth root of x to the third over fourth root of 2 times fourth root of x squared, fourth root of 8, and then multiply them. Either way, you're going to get the fourth root of x to the fifth over 16. You can rewrite this then as the fourth root of x to the fifth over the fourth root of 16. That's going to become x, fourth root of x over 2. Now multiplying, this is just like the distributive property that you learned in Algebra 1. When you multiply a monomial and a binomial, you multiply the monomial by the first term, then by the second term, and you're going to use the same rules. So we'll multiply 3 root 2 times 4 root 2 minus 3 root 2 times root 3. So that's going to give me 12 root 2 minus 3 root 6, not root 2, I'm sorry, that's root 4. Square root of 4 is 2. That's going to give me 24 minus 3 root 6. Remember to multiply those radicands together. Number 6, again, I'm going to have the third root of a times the third root of a minus the third root of a times the third root of a squared. This will give me the third root of a squared minus the third root of a to the third. Third root of a to the third, perfect cube. So I end up with the third root of a squared minus a. Scroll down a little. Okay, number 7, now I'm going to multiply these two binomials. And again, this is the same as what you've already done. It's just before you've done it with variables and integers, and now you're going to do it with radicals. So you're just going to FOIL first, outer, inner, last. So the first is going to give me 2 root 3 times 3 root 3. Then minus 2 root 3 times 2 root 5, outer, inner, plus root 5 times 3 root 3, and then last, this one over here, last will be minus root 5 times 2 root 5. So you can just do this multiplication. You're going to get 6 square root of 9 minus 4 square root of 15 plus 3 square root of 15 minus 2 square root of 25. So this becomes 6 times 3. We can combine those with the same radicands. That will give us minus the square root of 15, then minus 2 times 5. That gives me 18 minus the square root of 15 minus 10. So I get 8 minus the square root of 15 as my answer for number 7. For number 8, let's just do that down here. Remember that you're going to square this binomial, and that will give you a perfect square trinomial. Don't take a shortcut. This is 3 plus the square root of x minus 9 times 3 plus the square root of x minus 9. So again, you want to FOIL. First is 3 times 3. It's going to give me a 9. Then plus 3 times the square root of x minus 9 is going to be 3 square root of x minus 9. Then inner, same thing, 3 square root of x minus 9. Then plus, last, square root of x minus 9 squared. Okay, so think of that as a power to a power. When you have a square root squared, it becomes the radicand. So I have 9 plus 6 square root of x minus 9 plus x minus 9. So when I am finished, I have x plus 6 square root of x minus 9 as the solution for number 8. Now we're going to look at multiplying radicals with different indices. Before, they've all been the same. Now we're going to take a look at what happens when they're not the same. How do I handle that? So when I have the third root of 2 and the fourth root of 2, I'm dealing with like bases. So if I rewrite those radicals as rational exponents, then I know how to handle those. I have 2 to the 1/3 plus the 1/4. Like bases, add the exponents. So this will become 2 to the 4/12 plus 3/12, which gives me 2 to the 7/12. I can rewrite that then in radical form as the 12th root of 2 to the 7th. Now what happens when I don't have like bases and I don't have like indices? And this is a problem that students really don't pay enough attention to when I do it in class, and then on the test they end up forgetting how to handle it. So in this case, my indices are not the same, and my radicands are not the same. So I actually have to rewrite these and handle each of them independently, or get the indice to be the same. So when I look at this, I have 2 to the 3rd and 3 to the 1/2. In order to get that to a common index, I want to get a common index. I'm going to make that 2 to the 2/6 times 3 to the 3/6. Okay, so now they are the same index. Rewrite that as a power to a power, so this becomes 2 squared to the 1/6 times 3 to the 3rd to the 1/6. Now we have a rule that says that the product can be rewritten as then 2 squared 3 to the 3rd, all raised to the 1/6. And then you'll multiply those independently and have 4 times 9 to the 1/6. Which probably see that that's going to be 6. At this point, though, you may rewrite it as a radical, as radical notation, the 6th root of 2 squared times 3 to the 3rd. So pay special attention to this when you have exponents that are not, or indices that are not the same, and then you have radicands that are also not the same. You're going to handle that a little bit differently in that you're going to try to get them to have a common index, and then you can rewrite it as a radical, raise them independently to their powers. Okay, conjugates. This is the last part of this section. And a conjugate, if you remember the special product, a plus b times a minus b gives you a squared minus b squared. Remember, the very fact of FOILing causes those middle terms, one to be plus ab and one to be minus ab, and then they cancel. So the product of the sum and difference can be found by using that rule. The same rule is going to apply when we're looking at radicals. Multiplying a complex number, or a term that has both a real number and a radical as the second or first term, when you multiply by the conjugate, what's going to happen is you'll produce, when you FOIL, this idea of those middle terms being positive and negative. So let's FOIL this. 2 times 2, 4, then minus 6 square root of 5, plus 6 square root of 5, minus 9 square root of 25. They cancel. We end up with 4 minus 9 times 5, or 4 minus 45, which is negative 41. So again, let's look at multiplying conjugates to find the product. I have the square root of 3 times the square root of 3. That will be the square root of 9. Multiply those radicands. Then the square root of 3 times the square root of 2, so minus the square root of 6. Then the square root of 2 times the square root of 3 plus the square root of 6. And then the square root of 2 times the square root of 2, so minus the square root of 4. This becomes 3 minus 2, or 1. And the last problem for the notes is this square root of 2x plus the square root of y. Again, FOIL, so the first is going to give you the square root of 4x squared. Then outer is going to give you minus the square root of 2xy. Inner is going to give you plus the square root of 2xy. And last is going to give you minus the square root of y squared. 4x squared is a perfect square, gives me 2x. Middle terms cancel. Y squared is also a perfect square, so minus y. And then that is the solution to that problem. Your homework is in the note packet. Have a good evening, and I'll see you tomorrow.